Hello everyone, we are going to start the new lecture, that is process control system. So, if you remember in the last lecture we discussed what is bioprocess monitoring, why it is important particularly for the optimization and improve the productivity. Then we discuss the measuring of key physical, chemical and biological parameters. In today's lecture, we are going to discuss what is process control, what is the objective of process control, what are different types of process control, and once we are going to have a process control, what are the key components of a process control system. So, today's lecture will be basically overview of process control. So, process control, as the name suggests, it involves the use of monitored information to make decision that affects the process in a desirable way. So, you are having a process and you are having a monitoring device, you have monitored. Now, you have to by based on the, let us say, dissolved oxygen, based on the pH or based on the temperature, you have to consider whether process is going into right direction or not, and then you have to take a decision. And as you see this process control, it is very essential for different sector including manufacturing, chemical processing and biotechnology to maintain the consistency or minimize the variability, because if you know this is biological systems or any chemical reaction is taking place at particular conditions, and if you can maintain the condition, this consistency in the product can be ensured. What is the benefit? This effective control optimizes the resources, it reduces the waste and it ensures the regulatory compliance, particularly good manufacturing practices which are required for the further application or use of your product. So, what is the objective of process control? First is the product quality assurance. The quality control ensures product meet the specification, it reduces the defects and this customer complaints. So, what we are achieving? We are achieving the greater quality assurance by applying the process control. Process stability, maintaining the process variable within the limit, it prevents the disruption and protect the even equipment from the damage. So, it detects the problem and their location at an early stage. Operational efficiency, it optimizes the energy use, raw material used and production time. Finally, it improves the overall efficiency and lower cost. So, it ensures easier optimization of the process and more constant product quality. In addition, the safety enhancements, the preventing hazardous conditions and complying with regulations ensures a safe working environment. So, it has a very important role in the process industries. So, when we see any control loop, so there are going to be four elements. First is your measuring element, that is yours, for example sensors, and if it is temperature, let us say thermometer. Then next will be this information will go to controller. The controller will compare this value with a set point. What you have to do? We have to set a set point or your desired parameter, and instrument give a measured value, and difference between these two is called set point minus measured value. You can say this is the error, and based on this error signal it goes to the final control elements. Let us say there is a foaming is taking place and it will pump the anti-foam agent, and finally the process which need to be controlled. These are the four basic elements of a control loop. So, what is the role of sensor? The sensor measures the key process variables, for example, temperature, pressure and flow rate. What is the function of controllers? The controller analyze the sensor data and determine the control action by comparing with the set point using device from thermostats to controller. Then final control elements, let us say you are saying actuators. The actuators executes the control command by operating the bulb, motor or pump to maintain the process conditions. And further there is a feedback loop. The interaction of sensor, controller and actuator form a feedback loop to stabilize the process variables. So, this is generalized process control system. You can just see this is your process. So, whatever output is going, that is called controlled variable, and this is measured by your measuring devices, and this data is called measured variable. It is going to controller. Now, controller is comparing these two, the set point or desired value and measured value, and their difference it is sending as a control signal to the final control element, and then it is adding, taking necessary action, that is called manipulated variables. So, there is a controlled variable, there is a desired point, there is a measured variable and manipulated variables, and how the changes is coming, it may be due to certain disturbances. So, as I discussed, what is the error? Error is difference between set point value and the measurement signal of the which is coming from the controller. Let us say one example of hot water heater control system. So, you are having a hot water tank, your thermocouple is measuring the outlet temperature and it indicates temperature and you have set a desired temperature. The thermostat compares these two and then let us say it gives the signal to the fuel valve, and the fuel valve maintains, let us say, a burner to heat the system, and there will be certain disturbances like heat loss or hot water demand. So, in this way you can just see very simple example, the heating, or you can say the hot water tank heating process. In this case you measure the temperature, compare this temperature with desired temperature, and then necessary action will be taken, either heating or cooling. So, in the case of bioreactor, you just see this is your bioreactor, it is having a sensor and then sensor is connected with a controller. Final action will be taken by this actuator or final control element. Now, type of control, one option is you go for the manual control. So, in that case what you measured the value, then operator adjusts the valve manually based on the, let us say if it is temperature, based on the thermometer reading. So, you just see there is a flow here, you are having a temperature measurement, and based on that human operator it takes the decision, and then you will see whether heating need to be done or cooling need to be done. So, this requires continuous human attention and suitable only for monitor or infrequent deviations. Next comes automatic control. Here what happens, this you are having a thermocouple, this measured value is going to the controller and this controller compare with the set point, it take decisions and automatically the valve will be operated. So, it says it is having measuring element, it is having controller. So, it finally it reduces the labor and increases precisions, and different common type of controller are there: on-off controller, proportional controller, integral controller, derivative controller and proportional integral derivative controllers. So, this about the controller we will be discussing the last lecture in this module. A type of process control, one is the open loop control system. So, it operates without any feedback, then performing action based on preset instruction regardless of output changes. It has certain limitation like the system cannot adjust to disturbances, making them less effective in dynamic environment. Closed loop, what is difference? Here whatever measured output or you got, the measured variable you got is used to adjust the control action to improve the accuracy. What is the advantage? It offers the higher reliability and precision, and it is suitable for the critical application which requires the dynamic responses. So, now we can see what are the key components of bioprocess control system. So, there is a sensor and actuators. So, sensor measures the process variable like pH, temperature, diesel, oxygen or even biomass. And actuator, it adjusts the inputs like air, nutrients and heat. Then you are going to have different control strategies, and the control strategies can be open loop. Open loop means the measured variable is not coming to the controller, so you are going to do the manual control or manual adjustment based on the measurement. Closed loop, one example is automated feedback systems. You can have different type of controller which works based on the difference between set point and measured variable. Now we can have this advanced control, this model predictive control system or adaptive control systems. Further, there are supervisory systems like SCADA. This is known as supervisory control and data acquisition for real time monitoring, or DCS, distributed control system for large scale operations. In addition to this data acquisition and analysis is very important. So, there is it need to be integration of with software for data logging, trend analysis and further optimizations. So, these are the key components of bioprocess control system. First you need to have this sensor and actuator, then you go for the control strategy, it is open loop, closed loop or advanced. Then what are the supervisory systems are there and how this data acquisition analysis is taking place. So, as we discussed earlier also, this process control system have utility particularly in any manufacturing sectors or process industries. For example, chemical manufacturing, it controls the reactor temperature, pressure and flow rate to ensure the safety as well as efficiency in the chemical production. Pharmaceutical industry, it maintains a sterile environment, precise dose level which are critical for the product efficacy and safety. In food processing system, it manages the fermentation, it manages the pasteurization, manage the packaging to uphold the quality and hygiene standards. Oil and gas sector, it regulates the flow, pressure and safety monitoring in pipeline and refineries for secure operations. So, what it says this where you are able to monitor, it is important to go for the control system to maintain the optimum condition, to improve the efficiency, to improve the productivity. In addition to that, it is also important for the safety point of view. So, what we have discussed so far, we discussed the importance of process control. It ensures the stability of your process, the quality of your product, efficiency of the system and safety in the modern industrial operations. So, now there is advanced technology integrations. This advanced control strategies and technologies enhances the system capability and automation. Particularly the automation is very important to improve the overall performance of a system. Then innovation driving evolution. So, nowadays we have this biosensor technology, we are having this data analytics or artificial intelligence drive smarter. So, they are more adaptive to the process control system. So, what we have seen and what we have discussed here, that this modern technology, they can always be integrated with this process control systems. So, what we have discussed today is very simple. What is the process control? It says you have to take a decision, and for taking the decision you need to monitor. So, what you are monitoring is the measured variable. On measured variable you are comparing with a set point to get a error, and that controller decides and it sends a signal to the final control elements or actuators, which takes the action on a process to take necessary measures, and finally you are measuring the outlet, that is the measured variables. You are having measured variable, you are having the controlled variable. Control variable is the outlet temperature. So, basically you are monitoring the controlled variable, and this is going to controller and final control element. So, this is a closed loop system, but when you are just having a measuring devices and action is taken manually by the operator, that is called open loop system. So, it is very important to have a good monitoring device that we discussed in the last lecture, and after the monitoring you have to go for the control. What is the advantage of the control? It improves the quality, it improves the performance, as well as it ensures the safety of the process. Now, what are the different types of process control? So, we discuss it can be manual control, as I discussed, it can be automatic control, and if you just see, they can also be classified as open loop system or closed loop system. So, automatic control comes under the closed loop systems, and manual control comes under the open loop systems. So, I will stop here. Thank you so much.